Alright, let's look at an arithmetic series. And so an arithmetic series is one in which you have an arithmetic sequence, right? Something is, the difference between each successive term is the same, right? Like something's the same is being added every time. So if we jump down here to the middle, these are both arithmetic series because 2 is being added every time. It's an addition of an arithmetic sequence, right? So that's all a series is just adding those guys up. So if we come down here, there's a formula in order to get the sum of the first n terms of an arithmetic series. So if you recognize that the series is arithmetic in nature, then you can get the sum very easily by using that formula. There's the first formula, and here's the second. There's actually two. This is one that's used most common, the n over 2 times the first and the last one. It makes it a little bit nicer and faster to use, but either one would work. Let's watch them in action. So these formulas are just being given to you. They could be derived pretty easily, but he's not showing that derivation. So let's just focus on the use of them. So you'll want to have these written down or being able to easily referred to or memorized as the case may be. So if we want to add these terms right here, there's a few things that are super important. If you look at this formula, there's some things we need to know. We need to know the first term. We need to know the last term. You write term underneath there. And we need to know n. Those are what we need to know. So in this case, we know the first term is 2. We know the last term is 20, so we feel like we're golden, except we need to know how many terms that is. So how are we going to find n? Well, an easy way to find n is through just going to the formula. You know that an is equal to a1 plus n minus 1 times d. Well, we can see what all of these are. an is 20. a1 is 2. And that's what we're after. Now, what's the common difference? Well, what's being added every time? We would never use this formula unless we knew it was arithmetic. So there must be something added every time, and it's a 3. And then we would just solve. 20 is equal to 2 plus 3n minus 3. 20 is equal to negative 1 plus 3n. 21 is equal to 3n. And I know that works right over there, but I just thought it might help to just see it gone through live. And so you found out n is 7, so now there's a 7 over here. So now we're going to use that formula. 7 over 2 times 22, which is 77. So you could take your time to add those up, add up all those 7 terms, or you could use the formula. If you use formula number 1, it works out like this. I like using formula number 2, so that's what I'll highlight as we're together, but he does show the formula number 1 in there. So let's take a look at this one. We know the first term, we know the last term. Something is odd in here, and that is we have some negatives, but let's see how odd that is. It's not super odd. 3 halves going down to 2 halves is 1 half. So we're subtracting 1 half every time. So that's our common difference. So we know our first term, our last term, and our common difference. So what are we going to use? We're going to use this guy. That's your biggest friend with arithmetic sequences. And so we're going to have a negative 9 halves. That's got to equal how we started out times n minus 1 times negative 1 half. And you can see that being distributed here in this second line. Then we need to put, he's multiplying everybody by 2. That's a wise idea, right? Negative 3 is equal to 3 minus n plus 1. And then he's solving for n and finds out n is 13. So now that we know it's 13, we're home free with that second one. Remember, the second formula is n2 times a1 plus an. No problem. We just found out n was 13. That was the hardest part. a1 we knew from the beginning. an is negative 9 halves, and they do get added, right? And so he's going to do that right down here. So that's 13 halves times, well, that's negative 6 halves, or negative 3. And so what do we get? We get negative 39 halves. That's a great way to end it, and that's what you get no matter if you use Formula 1 or Formula 2. Here in example 3, um, arithmetic in nature, the common difference is right here. It's 3. So we would need to know, and we know this is actually better. We know how many terms. So we already know it's 15 divided by 2. We know, well, what happens when n is 1? What's a1? Well, a1 is going to be negative 1, so that's our first thing. And what happens when at the 15th term? The 15th term is going to be 45 minus 2, or 43. And so you can see those work out here. Did you see that the common difference was going to be 3? Now, he put out the sum, but with our work in section 1, we can know that, oh, that's going to just be an addition of 3 every time. That's what I saw when I plugged those numbers in. That's why we had you go through A1, is to make more informed decisions here. And so we get this nice sum out of there. Next one, k equals 1 to 12. Again, equally as nice. You can already start building this. The sum of those first 12 numbers is 12 over 2 times. And then we just need to know where we start. Plugging a 1 in, we get 5. Plug in a 12 in, we get negative 24 plus 7. So if we look at negative 24 plus 7, where do we end up? It looks like we end up, and we'll just double check down here, at I don't know how he's saying that that's formula 2. Oh, maybe I wasn't. Let's just double check my work here. Negative 2 times 1 plus 7 is 5. Now we're going to do negative 2 times 12 plus 7. That's negative 24 plus 7. And if I take 7 off of that, 4 off would bring me down to 20. 3 more off would be 17. And so I would have a negative 17. And so I'd have 6 times, and I'll make that a little bit more clear in here. Sorry about that. I believe I'm getting negative 17, and they're added together. So 17 minus 5 is negative 12. 6 times 12 is negative 72. So I believe we get a negative 72 in there. So he's saying 66. So that's where I'm getting a little bit confused. The common difference is negative 2, right? Coming out. I don't know why we need to know that, for especially using formula number 2. So there's 12 terms. The 12th term is negative 17. The first term is not 10. So I'm not seeing a 17 in there. So I think this is incorrect down here, based upon something else. Don't know where the 5 and the 12 minus 1 are coming from. And the negative 2, 12 minus 1 makes sense, but I don't know where the 2 times the 5 is coming from in there. So it seems a little bit confusing. But I do agree that the 12th term is 17. Does he ever find the first term? Oh yeah, he's saying that it's 5. And so am I. So that's where the 5's coming from. But I don't know where this 2's coming from. That seems a little bit odd. It's like he merged those two formulas here. And they're just not the same. So I believe the answer is negative 72 coming out of that. Okay. So small mistake there. And then, is there an upper bound to the sum of an arithmetic sequence? No. Because things constantly grow over time, it will get as big as you want, or in either direction, really big positive or really big negative. So if something's arithmetic, it grows without bound. There is no infinite sum. So he's just pointing that out as well. So hopefully that helps you navigate well through the homework. Let me know, though, if it doesn't.